Welcome. In this session, we're going to look at how SwiftUI and Combine changes everything. I'm Daniel Steinberg from editorscut.com and dimsumthinking.com. And so let's start. We are going to begin with a very simple iOS app. This app is just a button and a label, and you tap the button and you get a different random number. At the top, we have just a label, and at the bottom, we have a button, and we need to connect those to the view controller in our standard UI kit sort of way. So we need an outlet and we need an action. Here's our standard view controller. It is a subclass of UI view controller. Our outlet, which is connected to the label, is just called player display. The button is connected to an action called next. All that it does is it chooses a random number between 1 and 9, and then we have to turn that int into a string, and so we use description to do that. And now that it's a string, we can assign it to the text property of the UI label. What we have in front of us, of all the versions of this code that we're going to see today, this is the simplest possible version. The first bit of complication that I'd like to introduce is that instead of the button action setting the text field, I'd like it to set an actual property that holds an int. And so we'll introduce an int named player value, initialize it to 0, and now we can change the button action. So instead of setting the actual label's contents, it will set the value of our player value by choosing a random number between 1 and 9. And I like that a whole bunch more. I like that because the button doesn't know about the label. The button is just doing what the button should do. It's just saying I need to change a value somewhere. Now the problem with this is we no longer see the updates in the label. There's nothing telling the label, hey, something's changed, you need to update yourself. There are many ways to make that happen. What we're going to do is we're going to add this update display method, and the update display method takes the player value, turns that int into a string, and assigns it to the player display's text. It doesn't feel that much better than what we had before, except it's not in the button's action, it's in a private sort of helper method. The label still won't update when we tap the button because there's nothing to tell the label, hey, you've got a new value you need to display. And so that's one of the wonderful things that are in Swift. We can use the did set for the player value property. And so every time the player value changes its value or just updates its value, it will call that update display method. So we now have a wordier version of what we did much more simply before, but let's take a look at a slow motion replay and you'll see how the action happens. A user taps the button and that fires the next method. Inside the next method, the random number between 1 and 9 is chosen, and that is assigned to the player value property. The player value property now has this new value, and because it's been changed, it calls its did set method. Its did set method calls the update display. An update display is now called, and all it does is it takes that int, turns it into a string, and then displays it in the labels.text property. So let's see where we are in our modified version, in our second version. The next sets the player value, not player display.text. And what you're going to find out is that's a great warm-up for how we do things in SwiftUI. In SwiftUI, buttons don't know how to talk to labels. They don't have any way to talk to labels or even to themselves. And so what we do in SwiftUI is we're always modifying state, and then the SwiftUI runtime reacts to changes in states and updates the UI accordingly. Now in SwiftUI that's done automatically. Here we had to do that programmatically with our did set, and this communication of state change is a very important thing that we do explicitly in UIKit, automatically in SwiftUI, but that's a big part of what Combine is about. Combine takes these changes in state and communicates with those pieces that need to know about these changes in state. And so we're going to take a look at the SwiftUI and the Combine ways of looking at the world that build on this example. So here's a slight roadmap. We're going to re-implement this example that you've just seen with Combine. We'll implement it one more time with SwiftUI, and then we're going to grow the example slightly. Right now, everything is in the same file, and that's probably not the way you architect your apps. So we'll have more of a model and a view model or an adapter or presenter or whatever you call it in between the GUI and the model. Once we've grown the example, we'll implement that example with Combine and SwiftUI, and then we'll grow that example so that by the end we're making network calls and doing some more interesting things. So let's begin by taking our existing example and using Combine. So Combine, remember, is responsible for the part that takes the changes in state and communicates that back, so in this example, we update our UI. Here I've highlighted the code that we use to update the UI. It's the did set and the update display method. And so let's get rid of those, and we're going to replace those with Combine. In an example this simple, it might seem silly that we're using Combine, but we're using Combine in this example because it's easy and contained. It helps you see all the pieces. I don't think I would actually use Combine for something this simple. So what is it we need? In Combine, we need three basic pieces. We need a publisher, we need a subscriber, and we're going to have some sort of a chain from the publisher to subscriber where we might modify things along the way using things called operators. In addition, we need something to hold on to that publisher to subscriber chain, and that's called a subscription. So we need a publisher, a subscriber, and a subscription. So let's start by adding a publisher. And one of the things that UIKit has done is made it very easy for us to add publishers to our existing API. So we have this property called player value. By putting the @published before it, that's one of those property wrappers that was introduced last year, that's how we create our publisher. And now player value is an int, but $ player value is the publisher of an int. Actually, more formally, it is something that publishes an int and never fails. We have these two generics. One is for the type of output from the publisher, and one is what happens if there's an error. In this case, there's never an error. Second, in order to have a subscription, we need to import Combine. The @publish was part of UIKit, so I didn't have to import Combine at that point. But now that I'm going to introduce an any cancelable, a subscription is something that can be canceled. There's actually more to subscriptions, but that's all that we care about, is that it conforms to this protocol. And so we create this cancelable that conforms to any cancelable optional, and by making it optional, it's initialized to nil, and we only set it when we actually need to set it. So the subscription is going to be called cancelable. So the subscription is going to hold this chain from publisher to subscriber, and so we need to set it up somewhere. I'm going to do that inside of viewDidLoad. So here's where I'm going to set my subscription inside of viewDidLoad, and I'll start by setting it to the beginning of that chain, the publisher, and so it's going to equal $player value. The $ is to get the publisher. Without the $, it's just the int. So there's my publisher. I'm going to use the assign subscriber, and assign says I want to assign this to the text property on player display. We're using key paths here. And so player display is the receiving object, and .text, it's as if saying player display.text equals whatever it's being given, but it's being given it by a publisher, so it has to pull it out of the publisher and get its output. The subscriber is expecting to receive something that is an optional string, and it never fails. I can only use assign when it never fails. Unfortunately, the publisher is publishing an int and never fails. And so those two types don't match up. I'm sending out an int, I'm expecting to receive a string, or an optional string actually. And so just as you would in functional programming when you're working with arrays, I need to convert that int to a string. Combine has the map method that is the analog to the map method for array or for optionals. And so the map says, you give me a publisher of an int, and I'm going to convert that int into a string, and what I'm going to emit is a publisher of a string. And so map turns this int into a string, an int that never fails into a publisher of a string that never fails. Now, assign was expecting an optional string, but you know from Swift, if you're expecting to return an optional string and you return a string, Swift silently wraps that up in an optional for you if it can infer that that's what you want. So there's my chain from publisher to subscriber wrapped up in a subscription. So now let's see what happens when the user taps the button. The next method fires. The player value is changed to some random int between 1 and 9, and so player value has been updated, and so that's the update to player value. Player value, however, is a published value, and so the publisher sends it on down the line, and because cancelable is keeping this alive, the player value sends its publisher of an int that never fails. It is converted to a string that never fails, and that string is seen as an optional string, which is assigned to playerDisplay.text. And so playerDisplay is updated, and we see every time we tap the button, the new int is displayed. And in this case, we know that we're on the correct thread, but you don't always know that. So if you're about to do something that results in a change to the GUI, you should always push to the main thread, and we do that with the operator receive. And so we take whatever comes out of map and we push it to the main thread using receive on run loop main. And now we've re-implemented our example using Combine. Let's re-implement it using SwiftUI. Some of the implementation of our initial example was hidden because not only did we have our view controller, but we also did some of the work inside of a storyboard. And so inside of our storyboard, we dragged in our label and our button, and we organized them using stack views, and we control dragged to our view controller, so we connected our outlet and our action. And so we actually used the storyboard and the view controller to implement our app. In SwiftUI, we're going to do both of those pieces, but we do them in code. And so we start in the storyboard kind of place of it. We have SwiftUI that we import. Instead of a view controller, we're using something that conforms to the view protocol. It is a struct, it is a value type, which makes these things very light and easy. And the only thing you need to do to conform to the view protocol is you have to implement the body computed property. Body computed property returns something of type view. And if you think what we did in the storyboard where we arrange these things vertically using a stack view, we do the same thing in SwiftUI. We create a vertical stack that contains the text and the button. And you can see already, even though we haven't filled out the code, that the button can't possibly talk to the text or to itself because the text and the button have no names. They're not assigned to properties. There's nothing I can do to reach them. So that's why we have to introduce this property that holds the state, this player value. And now our text can display the player value's description. So we start off with the player value being an int that equals 0. So initially when this comes to life, we're going to see 0 on the screen because that's the player value's description. The button needs to display a prompt to the user, and it has to take an action. Our button is going to display the prompt next, and its action is going to be the method next, just as it was in the UIKit example. All that our next function tries to do is it tries to change the player's value by taking a random number between 1 and 9 and assigning it to player value, but this doesn't compile. So the way around this in SwiftUI is this state property wrapper. And the state property wrapper allows us to have something that can be mutated because player value is actually stored outside of the struct. And so it's a way of treating a value type by reference. This allows us to change an int that is being held inside of a struct called content view. To make this look a little nicer and space it out the way it was in our UIKit example, we'll add some spacers. And now our example works perfectly, and we've done it using SwiftUI. We started with a simple example where the button action directly changed what the label was displaying. In UIKit, we changed it to one that used an int property, and we changed the value of the property, and then we had to update the label. We replaced that updating in Combine using publishers, subscribers, and subscriptions, and then we redid it in SwiftUI using the @state property. So far, everything has been in a single file. It's all been in the view controller. We've had our player display, our player value, and next. And so what we want to do is take our model object and define it somewhere else and put our value and our next function inside of that. So something like this, where I have my view controller talking to a player. And so when you tap next on the view controller, it just turns to the player and says, well, call your next. And that next will find out what the value is, and it'll set the value. And we hope that it'll then display back in the player display. Now remember that problem we had in Combine, where player is holding on to an int, but view controller wants to display a string, and so sometimes we have a presenter or a view model in between, and this guy in between's job is to communicate from the view controller to the model, and also to translate what the model is storing into something that the view controller wants to display. In this case, it'll take the int and convert it to a string and take that back to the view controller. So the view controller owns the player view model, the player view model owns the player. When you tap next in the view controller, it turns to the player view model and says next, and the player view model turns to the player and says next. Hopefully, next will change the value of the player, and when that value changes, that change needs to be communicated back up the stack. And we're moving this player value and this next implementation to a class called player. So let's create player. Player is a class. Player is going to hold on to its value, which is an int. only player can change the value of int. We made it privately settable but publicly readable. And we moved the implementation of the next method inside, and so that value is a new random number between 1 and 9. And so next we'll set that, and so we feel pretty good about ourselves. We have created player. Let's work our way upstream, and let's create the player view model. The player view model must hold on to player. It creates an instance of player and holds on to it. And when you call next on player view model, it just turns to its player and says, you know what to do when you call next. And so it just relays that call to the player. And in between, it must be able to convert an int that it gets from the player into a string. And so that's where we convert the player's value into a string. And so there's our player view model. Next, let's look at the view controller once again. The view controller, instead of holding on to the player value, now it holds on to the player view model. It creates an instance of it and it holds on to it. And so again, when we call the next on the view controller turns to the player view model and calls next. That looks like we've got all three of our entities created. Now when we run the app, we see no results. We're calling next. Next is being called perfectly. You could check with a did set on the value inside of player to see that it actually is changing, but we don't see results because actually, even though we're communicating in this direction, we are not communicating back up. The player view model doesn't know the value has changed, and the view controller doesn't know that that value has changed, and so the view controller doesn't reflect any of the changes. Now we could do that with notifications, with key value observing. We could do it with closures and callbacks. We could do it with delegates. We have a whole bunch of tricks up our sleeves. What Apple has done is said, look, we're going to unify all of those asynchronous ways of communicating into Combine. And so let's do this with Combine instead. So let's go into player. Player is where we change the value and where we store the value. So let's import Combine there and let's publish our value. We just use the @published, and now when our value changes, it's going to publish it. Now that's only a small lie. One of the things about Combine is if you have a publisher but no one is subscribed to it, and that chain is not being held onto by a subscription, then nothing gets sent out. If no one's listening, there's no reason to publish the values. And so it is a publisher, and then once that publisher is connected to a subscriber and that subscriber is being held onto in a subscription, then it will start sending out values. But for now, we can say, look, we actually have implemented player for now. Let's return to the player view model, and it needs to also import Combine. And instead of this player as string being an easy property, our player value as string is going to be a publisher. We're going to subscribe to the player's publisher, modify the value, and then republish it. Here's our publisher that gives us an int and never fails. It is player.$value, so that comes from the player's published property. We use map to convert the int to a string, and so now our publisher is a publisher of string that never fails. Except if you look at the actual type, it is really this ridiculous thing. And so the way that we keep this from being propagated as we subscribe to things in different classes and structs is we use type erasure, and we erase this to just be a publisher of a string that never fails. And so the return value of our function, player value as string, is an any publisher. And I'm going to specify an optional string, and it'll coerce that string to being an optional string, and it will never fail. And so that completes our player view model. That brings us back to our view controller. And so in addition to importing UIKit, I have to import Combine. Once again, we're going to have to hold on to our publisher subscriber chain. And so we introduce a cancelable. And in view.did_load, we'll go ahead and start building our chain and storing it in our subscription in our cancelable. And so we start with our player view model. Player value as string, remember, returns an any publisher that publishes an optional string that never fails. And finally, we connect that to a subscriber with assign. We assign it to player displays text. And remember, we want to make sure that we receive that on the main run loop, just so that everything works out. And now we've got all of our entities talking in both directions to everybody. And so now we've re-implemented this using Combine, using 3 different entities. So when we tap next on view controller, it communicates that to next on player view model, communicates it to next on player, which picks a new int between 1 and 9, assigns that to value. Value is published player value as string is listening to that published and transforming it using map. And finally, view controller is listening to player value as string and subscribing to it and assigning the value that it gets back as a string to its text property in the label. Let's use Combine and SwiftUI together. If we move our Combine example to also using SwiftUI instead of UIKit, we don't have to make any changes to player.swift. It's just going to keep publishing out those ints that never fail. Content view is going to have to change to depend on our player view model. Our player view model is the one that changes the most. And also we're going to need to work with something called observable and observed objects. And so player's already taken care of, and we know how to communicate from player to player view model. So let's start in content view and see what needs to go there. Content view, instead of holding on to the player value, is now going to hold on to the player view model, just like we did in our UIKit example, except this time we have to mark player view model as an observed object. We're interested in knowing when it changes, because we're holding on to a class and SwiftUI updates its GUI automatically when it knows a change has happened. We have to indicate we're interested in knowing when these changes happen by marking player view model as an observed object. If you look at next, you see that as we did in our UIKit example, we just call player view model next. Inside of text, we have to display the player value as string that we get from the player view model. Player value as string is now a string. It is no longer a publisher of string. So there's a lot of changes that we're going to have to make in our player view model. Our view controller is all set, and that leaves us to work on our player view model. And so in our player view model, we've changed our player value as string to a string and initialized it to be the empty string. We're going to mark it as published. So whenever it changes, it's going to say, hey, I've changed to whoever's watching it. But because player view model is a class, and because my content view is watching my player view model, we need to mark our player view model as conforming to observable object. And what this does is, whenever a published property changes, content view gets notified that something has changed in player view model. You need to reload it. We're going to build a subscription, so we need to have a cancelable here. And now in our init, we build our chain, the same chain we had before, where we start with player.$value. That's our publisher of an int that never fails. Our map changes that to a string that never fails. And this time we're using assign to change the value of our string, player value as string. So when our int changes, we're going to store it away in player value as string. Now everything is working. We run our app. It works just as before. We tap our button and the int changes. The problem is assign strongly retains self. And so we have to use a different version of a subscriber here. Instead of using assign, which is appropriate if something never fails, we're going to use sync. Sync just takes a closure where it's past the published value, the string, and I'm capturing self weakly, and so this tells me I am not holding on to self strongly inside of this sync. And inside of this sync, if self exists, then I will set its player value as string to be string. I'm making a weak copy of self here, so I'm not strongly retaining. And of course, as before, we want to make sure that we are receiving this on the main thread. This has been quite a journey. We started with a simple version of our app here, and now that we have SwiftUI and Combine doing all the pieces, our now new version looks like this. And our app does nothing that it didn't used to do, but now it's in a position for us to expand it and give it new features. Let's turn this into a rock, paper, scissors app. I'm going to add handPosition.swift, which is just an enum that will hold rock, paper, and scissors, and I'll adjust player to work with hand positions for its value instead of ints. I'm also going to have to make a little trick where I ask player view model to drop the first value, but Combine lets me do that quite easily. So let's start with hand position. Hand position has 3 cases, rock, paper, scissors. It also knows how to create itself from an int. You give me an int, I will take it mod 3 in this case, and 0 will be a rock, 1 will be paper, 2 will be scissors, and so I can create a hand position from an int. And also I can describe itself. Now that enums start with lower cases, we'll just change it to uppercase when we're displaying it on the screen. And so there's our hand position. Now let's move to player. player has to work with hand positions instead of ints, and so when I tap next, it won't just pick a random number between 1 and 9, it will use that init to turn it into a hand position, and so our value will be stored as a hand position, and I'll initialize it to rock. I've initialized it to rock, which means every time I start my app, just like we used to always see 0 on the screen, we're going to see rock on the screen. That's a little more annoying when we have hand position than when we had an int. And so we're going to adjust the player view model to drop the first value so that it isn't always rock. How hard is that? Well, let's take a look at the change to player view model. We just put drop first there. And so we're subscribed to the stream of ints. We drop the first value, and then we keep going. And so now we've done all 3 steps that we need to implement rock, paper, scissors instead of displaying ints between 1 and 9. While we're at it, instead of generating a random int using int.random, let's get a random int from the internet. I've got an instance of Vapor up that is generating random ints, and so we'll hit that site to get our random int. The only thing that has to change is player, because player used to create its own int using int.random. Now it's going to have to hit the URL and parse the data it gets back. So we're going to use Combine for URL session. Let's create cancelable to hold a subscription. And inside of next, I'm going to check the validity of the URL instance that I vend from a constants file. I create my subscription by asking URL session to give me the shared session. We've done that for years, but this time we're going to use a Combine publisher. Instead of creating a data task and then resuming it, we're going to create a data task publisher for that URL. So now we have a publisher that publishes data, and now that we're hitting the net, it could fail. We reach inside and it's a tuple, and the tuple contains data and a response. We're going to just look at the data that we get back. We're going to take that data and convert it to a string. Now, if we try to convert this to a string using the UTF-8 encoding, that could fail, and if it fails, it gives us nil. And so what compact map does is it swallows up nil, and if it's non-nil, it unwraps the optional, just like compact map for arrays. Now I have a publisher of strings that could fail. I have to convert that publisher of strings to a publisher of ints, and I use compact map again because I might not be able to convert that string to an int. If I can't convert it to an int, compact map just says nothing ever happened, and if I can, it force unwraps it to the int underneath, and now I have a publisher of ints that could fail. Because it can fail for several reasons, I now need to use a more complicated version of sync. Sync could either end when I receive a completion or when I receive a value. So if I receive a value, it's going to be an int because I ended with a publisher of an int. So if I get a value, it's an int, and I take that int and I go ahead and use that hand position init to create a hand position from it, and I store it away in value. If instead I receive a completion, there's 2 kinds of completions I can receive in Combine. I can either finish or I can fail. If I finish, I'll print finished, and if I fail, I'll print the error. In my Vapor instance, I also have an endpoint that generates hand positions, not just ints, and so I can get a random hand position from the internet. And again, only player changes, well, for the most part. I have to have one other small change, and that is I take my hand position and I have to wrap it up inside of something at the Vapor end of things, so I'm going to have to unwrap it at this side. So I create something called random position, and it just contains a hand position. So what changes in player? My endpoint has changed, so I get a different URL for random hand position. Instead of taking my data and transforming that into a string and that into an int and so on, I take my data and I use a JSON decoder to turn it into a random position. I know, I wish it was harder. That's it. My sync is the same for completion, for finishing, and for failure. It's just different if I receive a value because the value is going to be of type random position. The JSON decoder transformed me from having a publisher of data that could fail to a publisher of random position that could fail. And so if I receive a value, it is a value of type random position. I reach inside random position, grab the position, and assign that to value. And that's how we deal with JSON. Real quickly, I'm going to finish up by saying, well, what if we want to play against someone? What has to change then? Well, there are changes to content view, changes to player view model, and a new game result. One of the things we like about splitting into different pieces is we know where to look in our app to make changes. So here's game result. Game result is I either win, I lose, or I draw. And I'm going to have different colors. I'll be green if I win, red if I lose, and just a gray if I draw. And I'll display different icons. I'll do a thumbs up if I win, a thumbs down if I lose, and a question mark if it's a tie. And so here's what the app looks like just quickly running. I can use that picker to choose my turn, and I hit go, and then it hits my server and pulls back a random hand position, and I find out if I win, I lose, or I draw. So in Content View, here's where I display the win, lose, or draw. It's one of these images displayed in one of these colors. So I'll get the image name and the image color from those computed properties in result, depending on win, lose, or draw. And then there's the picker. It let me allow you to choose rock, paper, scissors as your choice when you play. In the player view model, we have to publish the game result, and I'll start with it being a draw to start with, so I get a little question mark to begin with. And instead of a single cancelable, now I'm going to have more than one cancelable, and so I'm going to have a set of any cancelables. And so you'll see that in my init, here's how I store it in that set. At the end of the chain, after doing the sync, I'll say .store in $cancelables, and it'll store it away in that set. My second publisher is a zip, which zips together the player's value, the machine's value, and my final hand position, what I chose in the picker. It zips them together as a tuple, and then in the sync, I take that tuple, your result and my result, and I look at them together and I decide who won. If we tie, if me equals you, then my result is a draw. If me is less than you, then my result is that I lose, and otherwise I win. And that determines the colors and the images that I display. And so that's just a quick look at SwiftUI and Combine, and taking our standard architecture and seeing what has to change with Combine and SwiftUI. Notice that the two big things were this unidirectional flow of data, the fluidity of the data, how easy it was to subscribe to publishers and to split them and to combine them and have different people interested in different results. And the UI just responded to these changes so easily. And so I hope you've seen that SwiftUI and Combine changes everything. Thank you.